Here the electronic configuration of hydrogen is S1. In sp hybridization, two carbon atoms undergo 2sp hybridization. Okay, sp hybrid orbitals of two carbon atoms is linearly overlapping with 1s atomic orbital of two carbon atoms to form sigma 2sps sigma bond. Here sp hybridized orbital of one carbon atom is linearly overlapping with sp hybridized orbital of another carbon atom to form sigma sp bond. That means between carbon and carbon one single covalent bond is formed. Between carbon and hydrogen one single covalent bond is formed. Now 2py, 2pz orbitals of one carbon atom is laterally overlapping with or sidewise overlapping with 2py, 2pz orbitals of another carbon atom to form pi 2py 2py bond and pi 2pz bond. Between two carbon atoms, two pi bonds are formed. Already you know what is single covalent bond. The bond formed between two atoms, one pair of electrons are formed. Simply, one pair of electrons formed between two atoms in a molecule is called single covalent bond. Two pair of electrons formed between two atoms in a molecule is called double covalent bond. Three pair of electrons formed between two atoms in a molecule is called triple covalent bond. For example, if you take here a hydrogen, between hydrogen single covalent bond is formed. Between oxygen double covalent bond is formed. Between nitrogen atoms triple covalent bond is formed. Okay, between two atoms in a molecule one pair of electrons are formed, that is called single covalent bond. Single covalent bond is made up of one sigma and 0 pi bond. Two pair of electrons formed between two atoms in a molecule is called double covalent bond. Okay, double covalent bond is a combination of one sigma and 1 pi bond. Between two nitrogen atoms, three pair of electrons are formed, that is called triple covalent bond. What is triple covalent bond means? Three pair of electrons formed between two atoms in a molecule is called triple covalent bond. Triple covalent bond is a combination of one sigma and 2 pi bond. Okay, now I am taking here acetylene molecule. In this acetylene molecule containing one sigma single covalent bond, two single covalent bonds and one triple covalent bond. Single covalent bond is a combination of one sigma. Triple covalent bond is a combination of one sigma and 2 pi. Single covalent bond is a combination of one sigma. Total 3 sigma bonds and 2 pi bonds are formed. Then the shape of the acetylene molecule is a linear shape and bond angle is 180 degrees. Okay, this is information about sp hybridization. Now we will discuss one more, that is sp2 hybridization. Okay, sp2 hybridization means, what is the definition of sp2 hybridization? One s orbital combines with one p orbital. Sorry, how many? 2 p orbitals to give 3 sp2 new identical hybrid orbitals. This phenomena is called sp2 hybridization. Once again repeat. One s orbital combines with two p orbitals to give 3 sp2 new hybrid orbitals. This phenomena is called sp2 hybridization. Okay, the shape of s orbital is spherical in shape. The shape of p orbital is dumbbell in shape. These two are combined. 3 sp2 hybridized orbitals. This is one sp2 hybridized orbital, 2 sp2, 3 sp2 hybridized orbitals. In sp2 hybridization, the s character is 33.33%, p character is 66.66%. In sp2 hybridization, the shape of the molecules are trigonal planar, and the shape of the molecules are trigonal planar. Bond angle of the molecules 120 degrees. Example for sp2 hybridization: BCl3 boron trichloride, BF3 boron trifluoride, C2H4, etc. Now I am taking example here. C2H2, that is called ethylene. What is the chemical formula of ethylene, or it is also called ethene? It is also called ethylene. In the C2H4, each carbon atom undergoes sp2 hybridization. Atomic number of carbon is 6. Ground state electronic configuration of carbon is 1s2, 2s2, 2p2. The excited state electronic configuration of carbon is 1s2, 2s1, 2px1, 2py1 and 2pz1. Why ground state can be converted into excited state? The energy difference between 2s and 2p orbital is very small. Actually, carbon can form 4 bonds. That is the versatile nature of carbon, that catenation property, and it forms multiple bonds. Tetravalency. Catenation means self linkages of carbon atoms to form a bigger molecules, either straight chain or branched chain or closed chain, is called catenation property. It is a unique property. When the carbon atoms are connected with each other in a straight line or branched chain to form a bigger molecules are called catenation property. The valency of carbon is 4, that is a tetravalency, and it forms multiple bonds like double bond and triple bond also. That is the versatile nature of carbon. The energy difference between 2s and 2p orbital is very small. An electron jumps from 2s orbital to one electron from 2s orbital to 2pz orbital. That is called excited state. Electronic configuration of carbon is 1s2, 2s1, 2px1, 2py1, 2pz1. This is the electron configuration of carbon in excited state. Here, one 2s orbital, one 2px orbital, and 2py orbitals. These 3 different atomic orbitals of same element can intermix or combine to give 3 sp2 new orbitals. Okay, what is the shape of sp2 hybridization? Trigonal planar. Then the shape is, okay, this is the trigonal planar shape. 1 sp2, 2 sp2, 3 sp2. Each sp2 hybrid orbital having a unpaired of electron of one carbon atom. If you take another carbon atom, now I am taking here clearly, you can observe. Now I am taking here our convenient. This is 1 sp2, 2 sp2, 3 sp2. If you take another carbon, 1 sp2, 2 sp2, 3 sp2. 1 sp2, 2, 3. Okay, this is the trigonal planar shape. sp2, 2 sp2, 3 sp2. Only one atomic orbital, that is 2pz orbital, does not involving in the sp2 hybridization. That is called unhybridized orbital. It is also called pure atomic orbital. The shape of p orbital is dumbbell shape. The shape of p orbital is dumbbell shape. This is the 2pz orbital. Okay, now I am taking here also 2pz orbital in another color. Right? You can observe here. Okay, sp2 hybridized orbital of one carbon atom is linearly overlapping with sp2 hybridized orbital of another carbon atom to form sigma bond, sigma sp2 bond. And already you know hydrogen atomic number is 1. Electronic configuration of hydrogen is 1s1. The shape of s orbital is spherical in shape. Here in this there are 4 sp2 hybridized orbitals of 2 carbon atoms. These 4 sp2 hybridized orbitals of 2 carbon atoms is linearly overlapping with 1s atomic orbitals of 4 hydrogen atom to give 4 sp2 s sigma bond. sp2 s sigma bond. And third point is here 2pz orbital of one carbon atom is sidewise overlapping with 2pz orbital of another carbon atom to form pi 2pz and 2pz orbital. Okay, that's why here between carbon and carbon 1 sigma bond and 1 pi bond. Between carbon and hydrogen 2 sigma bonds are formed. That is 1 sigma, 1 sigma, 1 sigma and 1 pi, 1 sigma, 1 pi. Total 5 sigma and 1 pi bond formed in the ethylene molecule. Then the shape of the molecule is trigonal planar. Bond angle is 120 degrees. Okay, this is information about sp2 hybridization. Thank you. And one more hybridization is sp3 hybridization. Okay, what is the sp3 hybridization? How to define the sp3 hybridization? Okay, one s orbital combines with 3 p orbitals to give 4 sp3 new identical hybrid orbitals. This phenomena is called sp3 hybridization. Okay, s orbital is a spherical in shape, p orbital is a dumbbell shape. How many dumbbells? 3 dumbbells. Okay, the shape of s orbital is spherical in shape. The shape of p orbital is a dumbbell in shape. To form 4 sp3 identical hybrid orbital. 1, 2, 3 and 4 sp3 identical new orbitals. This phenomena is called sp3 hybridization. In sp3 hybridization, s character is 25% and p character is 75%. The shape of the sp3 hybridized orbitals tetrahedral shape. The bond angle of sp3 hybridization is 109 degrees 28 minutes. Here now I am taking examples. CH4, C2H6, NH3, H2O, etc. Now I am taking example CH4 molecule. In CH4 molecule, the central atom is carbon. It undergoes sp3 hybridization. Atomic number of carbon is 6. The ground state electronic configuration of carbon is 1s2, 2s2, 2p2. The excited state electronic configuration of carbon is 1s2, 2s1, 2px1, 2py1, 2pz1. Here 1s orbital, 3 p orbitals are combined to form 4 sp3 new identical orbitals. Okay, what is the shape of sp3 hybridized orbital? This is the shape of 4 sp3 hybridized orbitals. Okay, 1 sp3, 2 sp3, 3 sp3, 4 sp3. Each sp3 hybrid orbital having unpaired of electron. It is overlap with another element. Atomic number of hydrogen is 1. Electronic configuration of hydrogen is 1s1. Okay, in this 4 sp3 hybridized orbitals of one carbon atom is linearly overlapping with 1s atomic orbitals of 4 hydrogen atom to form sp3s sigma bond. sp3s sigma bond. Okay, this is the tetrahedral shape. Simply here 4 sp3 s sigma bonds are formed. Then the shape here, carbon hydrogen carbon hydrogen hydrogen tetrahedral arrangement. Then the shape of the molecule is tetrahedral and bond angle is 109 degrees 28 minutes. Okay, this is information about sp3 hybridization. And one more example, now I am taking here NH3 and H2O. NH3, the name of NH3 molecule is ammonium. NH3 molecule. In NH3 molecule, the central atom is nitrogen. It undergoes sp3 hybridization. Okay, nitrogen atomic number is 7. The electronic configuration of nitrogen is 1s2, 2s2, 2px1, 2py1 and 2pz1. Here this is s orbital, 1 s orbital, 3 p orbitals are combined to form 4 sp3 new identical hybrid orbital. Here what are the characteristics of hybridization? Hybridizations are involving in the sigma bond only but not pi bond. Only orbitals are involving in the hybridization but not electrons. Half filled or fully filled or even empty orbitals also participating in the hybridization. Okay, here 4 sp3 hybridized orbitals. In this 4 sp3 hybridized orbital containing, what is the shape sp3 hybridized orbital? Larger loop, smaller loop. Larger loop, smaller. Larger loop, smaller. But here two paired electrons are there. Two electrons are there. Here this is 1 sp3, 2 sp3, 3 sp3. In this 3 sp3 hybridized orbitals of nitrogen atom is linearly overlapping with 1s atomic orbitals of 3 hydrogen atom to form sp3s sigma bond. sp3s sigma bond. But the shape of the molecule is deviated from tetrahedral too. Okay, it undergoes sp3 hybridization means the shape of the molecule is not tetrahedral. Bond angle also not 109 degrees 28 minutes because here VSEPR theory. According to Vesper theory, to determine the shape of the molecules, repulsion between the electron pairs. Electron pair means sum of lone pairs and bond pair of electrons. What is lone pair of electrons? The number of electron pairs does not participating in the covalent bond is called lone pair of electrons. The number of electron pairs which are participating in the covalent bond is called bond pair of electrons. Okay, here lone pair of electrons, lone pair to lone pair is a more repulsion, then lone pair to bond pair, then bond pair to bond pair. Okay, this is one lone pair, bond pair. Between these two repulsive forces, the shape of the molecule is deviated from tetrahedral to trigonal pyramidal shape. Trigonal pyramidal. The bond angle also deviate from 109 degrees 28 minutes to 107 degrees 31 minutes. Okay, this is information about NH3 molecule. Next, H2O molecule. In H2O molecule, the central atom is oxygen. It undergoes sp3 hybridization. Okay, oxygen atomic number of oxygen is 8. Electronic configuration of oxygen is 1s2, 2s2, 2px2, 2py1, 2pz1. Here 1 2s orbital and 2px, 2px, 2py, 2pz orbitals are combined to form 4 sp3 identical hybrid orbitals. Okay, this is one sp3 identical hybrid orbital, and also one more sp3 identical hybrid orbital. These two are this is one sp3, one sp3. In this 4 sp3, 2 sp3 hybridized orbitals are paired means 2 electrons are there, and remaining 2 sp3 hybridized orbitals are unpaired electrons. Okay, here, okay, these 2 sp3 hybridized orbitals of one oxygen atom is linearly overlapping with 1s atomic orbitals of 2 hydrogen atom to form sp3 s sigma bond. sp3 s sigma bond. And here there are 2 lone pair of electrons are there. The repulsion between lone pair to lone pair is more repulsion when compared to the lone pair to bond pair. That's why more repulsion takes place between the lone pairs. The shape of the molecule is deviated from tetrahedral to bent shape. Bent shape means like this. It is also called inverted V shape. Inverted V shape. It is also called angular shape. Angular shape or bent shape. Or bent shape. What is the shape of food water molecule? Bent shape or angular shape or inverted V shape. The bond angle of water molecule is deviated from 109 degrees 28 minutes to 104 degrees 104 degrees okay, this is information about